Hello everyone, I'm Yang Liu, a PhD candidate at the Institute of Computing Technology, Chinese Academy of Sciences, and I'm also an intern at Alibaba Group. Today I feel honored to present our work titled Alike and Unlike, Resolving Class Imbalance Problem in Financial Credit Risk Assessment. Together with my co-authors, Professor Xiang Professor Qinghe from ICT-CAS, and Qi Weizhong, Jinghua, Fengjia Yutang from Alibaba Group. The corresponding author is Professor Xiang. The content of this talk could be listed as follows. First, I would like to introduce the background and motivation of this work. Next, I will explain our framework named ADAR to solve the class imbalance problem. Then I will demonstrate the performance in the experiment section and finish this talk with the conclusion and future work. The background of this work is credit payment, a kind of payment that you signed a contract to promise you that you will pay the bill before the due date. The most common instance of credit pay is credit card. Almost every one of us use it. Others like Ant Credit Pay and PayPal Credit Pay are also widely used. Credit risk assessment is to predict the probability that the user will repay the bill in time, and classify users into two groups, low risk and high risk. Most users belong to the low risk group and they repay the bill in time. Others will be default or fraud users, which is our goal to identify them. Although the number of high-risk users is small, their costs could be huge. According to the annual report, only 0.68% of return revenue in the US are high-risk payments, but their costs reach as high as $32 billion. Therefore, it is of great importance for us to identify these high-risk users, and the motivation of this work is to solve the class imbalance problem in credit risk assessment. One of the widely used solutions for this problem is data augmentation, as the right figure shows. Low-risk users are denoted as green circles and high-risk users are represented by red triangles. Our goal is to generate synthetic samples in red squares, which are alike the minority high-risk users and unlike the majority low-risk users. To achieve this goal, we propose an adversarial data augmentation method with auxiliary discriminator named ADAR. Three key components of our framework are generator G, discriminator D1 and D2. To make synthetic samples alike the minority class, D1 identifies the real samples from fake samples, and D1 and G are trained to minimize and maximize the adversarial loss respectively. Meanwhile, to ensure the samples unlike the majority class, D2 discriminates high-risk users from low-risk users, and both G and D2 are trained to minimize the cross-entropy loss. As we all know, it could be hard to train a good generator. Therefore, we train an encoder-decoder framework and the reconstruction loss to initialize the parameters of G, D1, and D2. In details, the parameters of D1 and D2 are initialized with encoder, and G is initialized with decoder. Experiments are conducted on a real-world dataset from an online credit payment service provided by Alibaba Group. We collect financial users from 3 months and construct 2 train and test pairs. For each user, we collect 908 features including this information, and the rate of minority class is around 1% across these 3 months. We compare with several state-of-the-art methods including interpolation-based methods like SMOT and ADASYN, and GAN-based methods like BAGAN and GLGAN to verify the effectiveness of our proposed methods. The main results of our experiments are shown in the table, and we can clearly observe that our model ADAR outperforms both interpolation-based methods and GAN-based methods. Ablation tests demonstrate the effectiveness of each component in our framework. Finally, we finish this talk with a conclusion and future work. In this work, we design and adversarial training framework to generate synthetic samples alike the real high-risk samples, and an auxiliary discriminator to assess the risk to make synthetic samples unlike low-risk samples. For future work, we think that designing cost-sensitive imbalanced learning methods could be an interesting problem. Meanwhile, extending this kind of augmentation methods to complex structures like graphs is also a challenging direction. Thank you all for listening. If you have any question, feel free to contact us at these emails.